Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are from group F1. We are going to present our report, which is PE1 control three-phase with rectifier. So as the first experiment, we determine the of the phase commutation angle point. So this is the voltage waveform, which is VR, VY, and VB that we obtained from the simulations. Okay, next, this is the computation angle point that we calculate from the simulation, which is 29.466, and we round to 30. Okay, so from this theory, the computation angle is related to the zero crossing of phase voltage is 30. However, from the based on experimental value that student generated, the computation angle point, the value is slightly different. This is because of maybe the causality is not exactly approximate to the computation angle. So since the circuit using three-phase supply, so if there has inductance in supply circuit, so the resistor will turn off as soon as the other phase exceeds the existing supply phase voltage. So the reference point for the angle of the delay is the point where a phase voltage will cross the previous phase and become positive. So in addition, the larger the delay, the lower the average magnitude of the DC voltage. But so after the observation of this experiment, the value of line commutation angle point is 29.592, and rate that can refer by the angle, which is 0, the alpha, which is 0. Okay. So the next one. So for the second experiment, which is the current voltage waveform of the converter for different release angles with resistive load, we do this experiment at release angle at 0. This is the waveform that we get, and then the delay angles 10 degree, and then 30 degree, and then 90 degree, and the last one is 100 degree. So from the waveform that we obtained in experiment 2, the different angles give the different shape of waveforms and values. This is because the firing angle has been injected with certain value of angle at the gate signal G1, G2, and G3. So when the firing angle is 90 degree, and afterwards the voltage and the current will become 0. Okay, as we can see in the 90 degree. Okay, so at the 90 degree, as you can see, the voltage and the current will become 0 and flatten due to commutation process. So from this experiment, what can be concluded is when the delay angles is between 0 and 30 degree, will not produce the delay on waveform and it continues mode. But when the delay above 30 degree and the delay angle will appear on the waveform mode, but when the angle above 30 degree, okay, so but when the delay angle above 30 degree, the delay angle will appear on the waveform in the discontinuous mode. So in conclusion, student can conclude that the delay was increased and the value of current and the voltage is dropped.
So for the third experiment, we calculate the voltage and power ratio of the converter using the different firing angles. So as we can see at the first, measure the average output voltage VDCO 67.519, and then we calculate the average output voltage VDCO. So the formula as shown, and we got 138.146 watt. So we use different angle for the alpha 0 to 100. So the result for the VDCO is based on the formula, and then from the previous table, we tabulate the data and build the graph. So we can see the graph decline from the 1 to almost 2, 0.2. So this is for the PDCO, graph for VS PDCO over PDC alpha over PDCO.
Dah.
So so based on the experiment, the voltage and the power ratio of the converter will vary by the verifier angle from 0, 10 to 100. So both of the graphs show that the decline of the values from 1 to almost 0.2. So this is due to the voltage drop that occurs during the commutation interval.
Okay.
That's it for the experiment.
Hello, my name is AZHARI bin AZMI, and I will discuss about the four experiment, which are current and voltage shape at the converter on mixed load, which is a resistant and inductive load. So first, we construct the circuit by adding 100 millihenry inductor in series with the resistor. So this figure is the circuit of resistor series with the inductor. And next, uh, so from the circuit above, we run the circuit at the 90 degree. So this circuit for this graph at the 90 degree, and then compare the result from the start balik. Compare the result from purely resistive load with the alpha angle at the 90 degree. So from the experiment 2, there is a resistor only that to be used. Meanwhile, from the experiment 4, there is a inductor that series with the resistor. So, based on the observation, the comparison between these two experiments is the waveform of the voltage output is different. It is because in experiment 4, the output voltage is negative due to existence of extinction angle. Meanwhile, for the output voltage in the experiment 2 is positive because for the thyristor to allow reverse current to flow, and output current need to be positive as well as output voltage. So next. So this table according from the 0 degree to the 100 degree. Okay, next. Okay, this graph based on voltage DC angle against the voltage DC node. Next. This graph for the power DC node against the power DC angle. Okay, lastly for the graph, what can we get for the experiment? The comparison can be concluded was the adding of an inductor with 100 millihenry. Based on the circuit, we use the same circuit from the previous experiment, but we add inductor series with the resistor. The output both of the experiment with R load and RL load were same in terms of output voltage and power, which is when the firing angle is increased, the output voltage and power will decrease. From the waveform output voltage, we observe that there is a different waveform due to the presence of inductance load. With an increase in the delay angle, the voltage and the power ratios decrease because the current flow is delayed. The greater the turn-on delay, the more the current lag, as its inductive load compared to purely resistive load. That's all.
So for this experiment conclusion, students were able to understand and discover about the three-phase control rectifier and the PC software. So students had built the circuit path in the lab manual. So diode rectifier only provide a fixed output voltage by using thyristor, and the rectifier can provide a controllable output voltage. It is also being tell from the quiz, so it also demonstrate by varying the firing angle, output voltage can be varied. So, aside from that, new skills have been acquired, such as ability to determine the phase commutation angle point, observe and analyze current, and voltage shapes converter by setting the delay angle and inserting the resistive inductive load. So, when created the commutation interval, it has been inserted the inductive load into the circuit. So, during the commutation interval, the thyristors stated current conduction at the same time. So, that resulting to the short circuit path. So at the end, the voltage dropped the interval that caused lowering the overall voltage and power measured. So like this, at the experiment, the graph decreased or lower the value. So in the experiment, the continuous and discontinuous conduction modes were learned. So the current waveform is in continuous mode when the firing angle is set to 0 or 10 angle degree angle. So the current waveform appears discontinuation when the firing angle is set to 30, 90 and 100. So this demonstrates the current in the energy transfer never reached 0 during continuous conduction mode in the discontinuous conduction mode. So, inductive current is not constant throughout the cycle and reach 0 even before and the end of this period when there are a few moments with no current flow. So overall, students should be able to conclude that the point of communication angle as reference point for delay angle where phase wave across the previous phase became positive. So as the second experiment, students are able to analyze the current and voltage waveform from angle 0 to 100. Each of the firing angle alpha has various output of the waveform where it can continue discontinue mode. So students also managed from this experiment to determine the control characteristic of converter for resistive load and mixed load, resistive inductive load. So lastly, students managed to analyze current and voltage at the converter with delay angle alpha equal to 90 degree. So the result during this waveform will appear in the graph shown in is inversely proportional. Thank you, that's all.